Thank you, Julie. And then we've got our final presentation for the session. And this is on recent technologies to enhance quality control and asphalt paving, federal highway efforts. So giving the presentation would be Dr. Ram Veeragaravan, and I tried to do this and I knew I was going to mess it up, so I apologize. But he's working for Federal Highway Works with the Mobile Asphalt Technology Center in the van. So thank you.
Thank you, Bruce. So today I'm just going to talk about the recent technologies that are being used by agencies to enhance quality control in asphalt paving. The usual FHWA disclaimer that I need to show, that we do not endorse or any products or manufacturers, and any methods and practices that I am going to discuss is not a federal mandate. A list of acronyms that I'll be describing anyways in detail. So I'm going to talk a little bit about our mobile asphalt technology program for a brief period, and then I'll just explain what we do. So in a nutshell, our program's goal is to take innovative research products and introduce these research products to state agencies and industry partners throughout the country. And so we are basically bridging the gap between research and implementation. So what makes us unique is that we collaborate with several state agencies and industries to introduce new innovative technologies that are either coming from national academic research or state DOT research efforts. And we field evaluate them on an active construction project. So we evaluate them in real time and real world conditions. So we actually accelerate the implementation and deployment by providing technical guidance, training, and through our equipment loan programs. So basically, we offer equipment loans so that the state agencies can actually try these equipments out and see if it fits their needs, and then actually invest in these new technologies. So MATC focuses on 3 key areas. Those are deployment, troubleshooting, and post-construction evaluation. So in terms of deployment, we offer a 2-day quality in asphalt paving workshop. So what we do in this workshop is we cover methods, practices, and potential benefits of a quality-focused asphalt paving to increase the durability of asphalt pavements. We are also in the process of recording short video briefs so that the state agencies or any personnel can look at these videos, short video briefs, and quickly know and learn what this technology does and what benefits it can provide. In terms of troubleshooting, while we are on site, we provide assistance within the scope of the standard or agency specification. And if state requires in-depth evaluation, we do that through our partner program, which is Asphalt Binder and Mixture Laboratory Implementation Delivery Division. This is a stationary lab which is situated at the Turner Highway Research Center back in Virginia. So in terms of post-construction evaluation, we do non-destructive testing to evaluate the field conditions, or we do the construction monitoring. And we also provide assistance in the maintenance and preservation treatment selection, and also we assess pavement surface characteristics such as macro texture or skid resistance of asphalt pavements. So our team consists of members having expertise in different areas of research as well as in paving industry. So this program is being led by Leslie Myers, who's my boss, and she's the federal program manager for this program. And then we have Derek Ninaplant, who people of Maine DOT would know probably. He's a materials and pavement engineer, and he assists us with this program. And then we have Brendan Morris, who is a project manager and has more than 30 years of experience in plant operation and paving practices. Then we have our laboratory and field technicians, James, Jonathan, and Otto, who provide their expertise in laboratory and field operation. And then myself, who is looking onto the data analysis aspect on a national scale. We also do have subject matter experts like Nam Tran from NCAT and Mike Huner, who provided assistance through reviewing material and construction specifications. So we have members with different expertise on different areas. So in terms of the technologies that we are offering, this can be basically broken down into 3 major categories, which are mixture, material, and field. So for this presentation, I'll just be focusing on the field aspect, but we do offer mixture and material testing. So in terms of mixture testing, we do offer tests that you may have heard through the term balanced mix design. So in terms of cracking, we offer tests such as ideal CT, Illinois flexibility index test, and overlay test for reflective cracking. And for rutting, we have the ideal RT and the Hamburg wheel tracking test. We do also AMPT suites of tests that are used to characterize fundamental engineering properties like the dynamic modulus, cyclic fatigue test, and stress sweep rutting test. In terms of materials, we do offer technologies that are the tools that can provide can be used as a forensic tool and as a quick QC tool. So in terms of the material tests that we have are the handheld XRF or the X-ray fluorescence, which DOTs are using to find contaminants in asphalt binders. So contaminants in the sense like the recycled engine oil bottoms in asphalt binders or titanium dioxide in paint markings as well. In terms of ABT, the next technology is the ABT or the asphalt binder tester. That's another tool to quickly predict the true grade of asphalt binders. So this tool can be used as a screening tool to know what grade of binder we are getting from the supplier. And next we have the FTIR for doing binder analysis on the molecular scale. So to find presence of amines in amines and anti-strip agents or aging characteristics of asphalt binders. So the focus that I'm is on this field technologies. So all these technologies that I'm going to talk about are looking onto the post-constructed pavements. So the first technology is the pulse induction technology. It's a non-destructive tool that is used to find the in-situ thickness non-destructively. And the second is the laser texture scanner that is used to measure pavement macro texture. And the paver mounted thermal profiler that is used to identify any potential thermal segregation. And the last one would be the dielectric profiling to continuously assess compaction quality. So the first technology that I'm going to talk about is the pulse induction. So this device is a non-destructive tool, and it is used to find in-situ thickness of both asphalt and concrete pavements. It has been predominantly used in concrete, but now that we are trying to deploy and encourage state DOTs to use on asphalt concrete as well. So this device quickly measures the asphalt pavement thickness, and you don't need to take course for this one. So it eliminates the need for taking course. The only requirement is that the device requires pre-placing thin metal plates or target plates before paving. So once the pavement has occurred over this plate, we use this device to go detect this plate, and then the distance between the plate and the surface is being measured and displayed on the screen, as you can see on the top right corner. So the thickness measurement is almost real time, and it quickly gives you the pavement thickness. In terms of the metal plates, the size of the metal plates depends on your target design thickness. So a typical in-place for an in-place lift, it typically is about somewhere between 2 to 4 inches. So for a 2 to 4 inches lift, we use a target metal plate that's the size of about like 3 inches or about 7 centimeters. And we place them before the tack has been placed. And then the tack comes over, and then the construction happens. And then we use this device to detect this metal plate. So In terms of advantages, it has many advantages. It's quick and easy to use, and it's more precise as well, close to a millimeter. And it provides significant cost savings in terms of like avoiding cutting costs. And it also is capable of storing the data as well. So here's another case example from our past site visit project in Vermont. It's an SMA project, and we had pre-placed 3 target plates spaced about like 250 foot or 80 meters in the longitudinal direction, and about like 3 foot apart on the transverse direction. So to cover an entire lane width. And we found that both the non-destruct, the pulse induction measurements and the field core measurements, the field cores that were taken right underneath where the measurements were taken, we compared them against each other, and we found that they were pretty much accurate, close to a millimeter. So here's another case example from our site visit project in North Dakota. And you can see here, like we haven't placed any, we didn't place any metal target plates at the center of the lane. The reason being is like states like some states use windrow paving. So one of the issues that Minnesota had previously experienced is that like when using windrow paving, there's a chance that the paver could pick up the plates. So in order to avoid that issue, like we didn't want to interfere with the construction paving crew. So we just placed them apart and then took the measurements. And over here as well, like we found that there's a good correlation up to close to a millimeter. So this technology also records the GPS geospatial coordinates, so that in the future, if you'd like to go back and trace the thickness, you could do so. So the next technology that I'm going to talk about is a laser texture scanner that is used to measure the macro texture. So what do I mean by macro texture is it's a term that's used to quantify pavement surface friction characteristics. So the surface characteristics of an asphalt pavement is predominantly influenced by 2 factors. One is the micro texture and the macro texture. So micro texture refers to the roughness of an individual aggregate surface, whereas macro texture refers to the void spaces between the aggregates, as you can see over here. So the macro texture is as I mentioned, it's a void space that helps in evacuating the surface moisture. And right now, as of now, there's no perfect test to measure texture at highway speeds. So FHWA is like currently investigating macro texture testing procedures that can be used in mix design, mix verification, and field verification. So one of the methods that is being used to measure macro texture is this laser texture scanner. So this device is lightweight, portable, and it's rapidly takes the scan of the surface within under 90 seconds. So this device uses a 4-inch laser scanner or a 100mm laser line scanner that travels across 100 millimeters or 4 inches to get a 4x4 square area. So because of this smaller footprint, it can be used on laboratory compacted gyratory specimens, or as well as on field cores as well. So here's an example from the same project. And we conducted the test, and we compared it to the sand patch test, which is a standard test that is being implemented by most state agencies. And what we found is like there's a good correlation between the sand patch test as well as the rapid laser texture scanner. And these values are typical as per AASHTO 2008 AASHTO guide for pavement friction. So the AASHTO guide for pavement friction specifies that for an SMA or an open graded friction course, the typical values are somewhere above 1. So a lower texture, macro texture reading would mean that the pavement is more prone to skid resistance, and a higher macro texture depth would mean that it's more good in texture. Here's another example from our site visit project in North Dakota. Except like now here, you don't find a good correlation with the sand patch and the laser texture scanner. But these values are typical for as per AASHTO 2008 pavement guide for friction. The only exception is like some states like North Dakota and Washington have a practice of post-fogging their new pavements. So they feel that post-fogging the new pavements would increase the service life of asphalt pavements. But with any laser measurements, this post-fogging would make the surface too reflective. So if it's too reflective, the laser texture won't be able to get good readings. So that's where you see a spike in the macro texture reading over here, which shows that the texture is too good. But the efforts are still being done to see like what can be done in case of post-fogging and how to actually evaluate them to get good readings. So the next technology that I'm going to talk about is a paver-mounted thermal profiler. So this device is a high precision real-time thermal profiler that is used to detect matte defects before compaction. So this the goal of this device is to it provides a two-dimensional heat maps, as you can see over here, and it is mounted on a paver up about like 2 to 3 meters behind the screen. So the device is pretty simple. It has an IR scanner, and that's being mounted on a mast that is bolted down to the paver, and it has a DMI or digital measuring instrument to record the paver speed, as well as a screen to view these heat maps actually. So in addition to this data that is being collected, this technology also offers cloud services. So this data can be viewed in real time by both the contractors at the plant as well as the DOT personnel at the office. So by doing so, like by viewing this data in real time, it increases the efficiency and the communications between the plant and the paver personnel. So here's the example from the same project in Vermont. This is an SMA project, and Vermont suspected that they may have issues with thermal segregation. The reason being is like the haul distance for this mix, SMA mix, was more than 2 hours. And they suspected that there would be a potential drop in the temperature. But as you can see from this heat maps, like we didn't find much thermal segregation. Overall, the paving was consistent, and they are pretty much using a flow buoy. So the flow buoy truck to deliver the mixes, and it was capable of retaining the temperature for more than 2 hours. And the spots, as you can see, like there may be some lower density spots, like you can see over here, the blue spots. So these blue spots would represent a lower temperature that are either caused by paver stops or lower paver speeds. And the streaks of gray lines that you see over here are the paver personnel walking in front of the sensor. So you need to train the paver personnel as well, not to make sure that they interfere with the sensor readings as well. And as I said, like it also has a DMI, distance measuring instrument. So it records the paver speed as well. So we checked the paver speeds on both production days, 2 different production days, and we found that overall they were consistent. So here's another example from Florida. And I just placed the paver speed and the thermal map side by side, because like here for this Miami, Florida project, they never used MTV, or the material transfer vehicle. So because they were since they were not using the MTVs, as you can see, like the paver speed reduced after every 150 linear foot. So a typical end dump truck would carry about like 150 foot of material. So you see over here, like there's a significant drop in the temperature. So these blue spots that you see that are occurring every 150 foot are potential areas of low density. And this make the potential issues that may arise in the future. Here's another example showing the paver stops. And so as you can see that as the paver stops, like you would see a drop in the temperature as well. And the last technology that I'm going to talk about is the dielectric profiling system. And as Professor Ishan already covered, I'm just not going to talk more on the technical aspect, but I'm just going to talk briefly. So this dielectric profiling system, again, it provides continuous assessment of compaction quality. So it measures the density. It actually continuously measures the dielectric values, not actually the density. So these dielectric values are then later correlated to density through calibration, curves, and etc. So the device that I'm showing over here is almost similar to a push cart, and it has about like it has 3 sensors that can be rearranged in any way, any fashion. So about like 2 passes of this dielectric profiling system would give you a full coverage of an entire map. The advantages are like it reduces the turnaround time, avoids cutting course. And as I said before, it measures the dielectrics, and the dielectric values are then later correlated to density. So a lower dielectric value would ideally mean like it has a low density, and a higher dielectric value would mean a higher density. And the dielectric profile system comes with a tough pad, which shows the heat maps, as you can see over here, the left sensor, the center sensor, and the right sensor. And as you push the cart, you would actually get this data in real time, and you would be able to identify potential low density areas and high density areas by just looking at the dielectric values. So these dielectric values are then correlated to density by fabricating gyratory specimens and then relating that to density. So here's the heat maps that we generated from the same Vermont project, and we did post evaluation on the data, and then we did some data smoothing. And these heat maps would provide information on the joint density aspects as well, and potential low density areas, identifying potential low density areas, etc. And we also did some analysis on the North Dakota project using the software called Veta. So this is a tool that is being that was developed by Minnesota DOT, and it's a tool that maps and provides data analysis by integrating intelligent compaction, the thermal profiler, as well as the dielectric profiling system. So it integrates all these 3 technologies in one platform, and these 2 figures don't do justice on that one, but it provides you the overall aspect on what the software is capable of doing. So as you can see, like it's capable of providing histograms, which shows a normal distribution pattern, and as well as you can, it provides heat maps that can be viewed on a Google Earth's image. So this technology is being deployed in many agencies. Minnesota is running on this one. Alaska is trying to make a spec as well on this one. Several other states are also trying to see the potential benefits of this dielectric profiling system. And if you wish to know more about our program, please reach out to us or even our program manager, Leslie Myers. And you could, if you want to know more, you can visit our website, FHWA MATC. Thank you.